In this lecture, I'm going to show you how to remove a node by its index in a doubly linked list. Over here, I'm going to call a method remove. Remove will take in an index, and that is it. So the index within our list that we want to remove the specific node from. All right, here we're going to check if the index is out of bounds. I'm going to come over here to the top and copy this edge case from the insert because it's exactly the same. So this will check if the index provided as an argument is less than 0 or a negative number, or if it's greater than the length. All right. Next is we're going to check if the index is 0. Equally so, I'm going to take this index here, or this from the insert method, paste below. The only difference is we're not going to call unshift here. So because we are removing something, we're not going to use unshift. Instead, we're going to use shift. So shift is the opposite of unshift. Shift removes, unshift adds to the beginning. All right. So there's that. Next is we're going to check, is the index for the end of the list? So in this case, we're going to do if the index is equal to this dot length minus 1, then we're going to call or return this dot pop. Pop is a method that we also created here for our class in a previous lecture, and you can see it's right over here. So pop removes a node from the very end of our list. So there you go. That is our initial setup for the remove. Yes. All right, so now we want to set up some variables. We're going to set up a previous node, current node, and current nodes next. All right, so we're going to need an initial place to start our traversal of the list, and that is the current node, which will be at the head. This dot head. And I'm going to declare but not set a value for a previous node, and also for current nodes next. I'm calling it current node next because this is say we're targeting to remove this one here. So at the point that the loop finishes, this will be the current node. So I want to create a variable that refers to the node to the right of it. So since this is current node, the current node next, which is called here, refers to the node next to the current node here. All right, and this will be the previous node. Okay. Next is we're gonna loop while. Let me see here. All right, loop while the loop index is not equal to the argument in the index. For this method, I'm not gonna use a while loop. Instead, I'm gonna use a for loop because I'm gonna switch it up. We've been using a while loop frequently, so let's go ahead and switch this up. So since we're using a for loop, then that means we don't have to set up like a counter variable or anything like that, because we know that the for loop allows us to set up an index here or initial counter. So for this, we're going to set up the I, or the index of 0, and then we're checking if the condition is to loop so long as the index is less than, or I should say the index is not equal to the index that's provided as an argument. All right, so if they're not equal, then we're gonna run through this loop. Otherwise, if they do, then that means both indexes were equal. All right, and then of course each iteration we want to increment the index. All right, so as we enter this loop, what we want to do is we want to update the current node. So the current node, each loop will advance it to the next pointer or to the next node by doing current node next, and then making that the new current node. All right, so once this condition is falsy, it would exit the for loop, meaning at that point we arrive to the specific location within our list that we want to make the removal of a node. All right, so for example, say we want to remove this 24 here from the list. That will be at index, let's see, this is 0, 1, 2. So at index 2. So let's do a basic setup here. So list.remove, and then pass in that argument of index 2 here. Okay, so this will continue to loop. This for loop will run until we arrive here. So what I want to do is I want to store a reference. Once we arrive here, I want to start setting up or giving these two variables a value. So the previous node, we can give it the value, this right here, by doing previous node will now be the current node.prev. Now this is one of the good things about the doubly linked list is now we not only have the next property, but we have the prev. So we can do this here. We can do current node.prev to point to, if this is the current node, doing current node.prev will not point to this here. So now I have a reference here, previous node, to point to here. But now I want to store also a reference to the current node's next, which is a 75. So the way I can do that is, all right, so that's this right here that I'm trying to give a value to. So current node dot next, I would give it the value of the current node dot next. All right, so now this variable here stores the node for 75. All right, so now that we have a variable with storing this and we have variable storing this, what we can do now is the first step I want to do is have this 7, which is stored in the previous node, to point to 75. So let's go ahead and make that connection. So I'm going to do previous node dot next. I want that to point to the current node next. All right, so this creates a pointer from 7 to 75. But now remember, because we're dealing with doubly linked lists, we have to have the 7. Now we want to have the 75 point to the 7. So the way we'll do that is we'll have the current node dot next, meaning this, its previous pointer to point to the previous node, which is here. So now that we had 7 point to 75 and now 75 point to 7, then automatically the disconnection of this disconnection automatically occurs here, where 24 is no longer connected to any of these, nor the 7 nor the 75. So we can delete that, and now the connection is between 7 and 75, like so. And because we are removing, we're going to have to decrement the length of the list. So this dot length minus minus, and then we're going to return this. All right, so that is everything here based on the pseudocode here. We make the previous node point to the current node's next, and we make the current node's prev point to the previous node, and then we decrement it, and then we return this. All right, so now let's go ahead and test this out. So you see here we're pushing in 4 values, and imagine that the 24, it still exists there, but the outcome is once we use this list.remove or the remove method at index 2, it's going to remove the 24 and create us this list here, a length of 3 now. So I'm going to go ahead, expand the console, run our code. Okay, a length of 3. I'm going to expand, look at the head. So the head is 2, which is here. And to the right of that should be 7. Here you see 7, and to the right of 7 is 75. So let's go ahead and expand that 7, and you see node of 75 right there. And if we expand that next, it's null because 75 is the tail. Now what if we go backwards? We see that go backwards from 75. Well, to the left of it is 7. So let's expand that previous here, and we see node of 7, and to the left of 7 is 2. So let's go ahead and let's see here. Wait, let me see here. All right, so we're getting a node of 7 here, and then to the left of the 7 is the node with 2 here. Okay, and if we expand that prev, we see that the previous to the 2 is null. All right, so now we have a method, a remove method that removes a specific node based on the index provided as an argument.